Okay, so good morning everyone. Now I am going to share the screen. Okay, this is our second day of acid base salt. So today we'll discuss about a base. Okay, in the previous class we have discussed about acid. Today we are going to discuss about base. Okay, so in acid, right, uh, so in acid, we have learned that uh, the substances which gives or chemical substances which gives H plus ion after dissolving in water, that is called acid. Okay, and obviously it is sour in taste due to the presence of or we can say it gives hydronium or hydrogen ion after dissolving in water. Okay, and then after we have discussed about different types of acid on the basis of source, we have learned two types of acid, that is organic acid and excuse me, and inorganic acid. Okay, organic acid that is obtained from plant and animals, and inorganic acid that is obtained from minerals or that is synthesized in the laboratory. Okay, and obviously organic acid we used to consume it, so it does not corrode or it is not corrosive in nature, but uh, uh, inorganic acid that is synthesized in lab and having a large strength, and so it is corrosive in nature. Okay, and that is uh, inorganic acid. After then, on the basis of ionization capacity, we had learned two types of acid, that is strong acid and weak acid. Strong acid that gives more hydrogen ion after dissolving in water, that is called strong acid, and it completely dissociate into ions, means as it dissociate more into ions, that's why it gives more hydrogen ion. And another is weak acid, that is the acid which gives less H plus ion, and giving less H plus ion means it partially dissociate into ions. After then we had learned about the physical properties. Okay, it is sour in taste, it turns blue litmus paper into red, and after then others also methyl orange after then into colorless, or methyl orange into pink color, or methyl orange into red, and then phenolphthalein into pink colorless, that we had discussed. Another it is good conductor of electricity. Then after then we had learned about the chemical properties. Acid reacts with metals to give the respective salt and hydrogen gas. Acid reacts with metal oxides or base, we can say metal oxide and hydroxide, and gives what gives respective salt and water. After then we had learned about acid reacts with a metallic carbonate to give carbon dioxide, water, and respective salts. In the same way in the bicarbonates. Okay, so this all we have discussed in case of acid. Now we are continuing about the base. I think uh, you all are able to see the screen. Am I right?
Yes, sir.
Oh, okay. Then base. As we have discussed in case of acid, we'll discuss. We'll add some more in base also. But the common definition of base, that is the metallic oxide and hydroxide. Okay. Metallic oxide and hydroxide, they are called base. It means if there is a metal, any metal, and their it combines with oxygen. For example, you can see here magnesium is a metal and oxide, calcium is a metal and combined with oxygen, sodium is a metal combines with oxygen, potassium same, sodium, potassium, magnesium, and then copper, this mercury, aluminum, others. So these all are metals, except you can see here NH4OH. Here is no any metal, but this is also a base. This is exceptional case. Okay, so except this, all other metallic oxide and hydroxides, that are called base. Okay, after then obviously some bases are dissolved soluble in water and some are not. So those bases which are soluble in water, that are called alkali. You know about this from class 8. The base which dissolve in water, that is called alkali, and which do not dissolve in water, that is the just base. And about alkali we have learned in the chapter classification of elements 2. So if you see here all the alkalis, in case of alkali, look here, in all the alkalis there is OH group. OH, 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 OH. It means metallic hydroxide. Okay, metallic hydroxide are called alkali. We can say simply metallic hydroxide are called alkali, and metallic oxide and hydroxide, they are combined form, that is called base. Okay, so we can say alkali is derived from base. Okay, after then so here is written all alkalis dissolve in water, but all bases do not dissolve in water, and so all alkalis are bases, but all bases are not alkali. After then here is a note: only some bases are soluble in water. Okay, colored is blue but looks black only. Okay, only some bases are soluble in water, and okay, and ammonium hydroxide NH4OH is only alkali which does not contain any metal. After then types of base, as we have learned in the previous class, here is no on the basis of source. So on the basis of strength only we can say, on the basis of strength or means ionization capacity, bases are classified into two groups, that is strong base and weak base. So a strong base, in case of a strong acid we learned more H plus ion. So in case of base we will write here more OH minus ion, because base contains radical OH. Okay, after dissolving in water. So strong base, the base which gives more OH minus ion after dissolving in water. Keep it in mind. First we have to dissolve this acid or base in water to give respective either in hydrogen ion in case of acid or OH minus ion in case of base. Okay, so the base which gives more OH minus ion after dissolving in water is called strong base, because it completely dissociates into ions. As it completely dissociates into ions, so it gives more OH minus ion. But keep it in mind, sodium hydroxide and potassium hydroxide, they are the good example of strong base. I want to repeat it. Sodium hydroxide and potassium hydroxide, they are the good example of a strong base. Magnesium hydroxide and calcium hydroxide, they are not assumed to be the strong base, example of strong base. Keep it in mind. But in our book, it is given like this, and somehow it is utilized in widely used, and that's why it is treated as a strong base. I want to repeat it again. Sodium hydroxide and potassium hydroxide, they are strong base, but magnesium hydroxide and calcium hydroxide, in case so they are not the strong, actually they have not too much capacity like a strong base have, but they are assumed as a strong base as it is widely used in lab for performing different activities. Okay, so that you have to keep it in mind. But if you're in examination, if it is at whether calcium oxide is a strong base or weak base, you have to write a strong base. Okay, after then weak base. So after then same, the base which gives less OH minus ion after dissolving in water is called weak base, and weak base NH4OH, FeOH3, or ferric oxide hydroxide, copper hydroxide, etc. Difference between a strong base and weak base I have written here. It gives more OH minus ion after dissolving in water. It gives less OH minus ion after dissolving in water. It almost completely dissociates into ions. It partially dissociates into ions. This is the same difference as that of the acid, a strong acid and weak acid. The difference one here is, in place of OH minus, you have to write there H plus, air OH minus, in place of that, we have to write H plus. So they are same. Azur?
All alkalis contain alkali metals.
No, all alkali do not contain metals. As I told you, NH4OH is alkali, but it does not contain any metal.
So which contain metals? They are all alkali metals, yes?
Here we can say alkali. No, we can't say alkali metal. Alkali metal, no. Actually, assumed as a, because they are not going to form alkali as usual. It is a bit difficult. Ferric hydroxide, copper hydroxide, these form takes too much long time after to dissolve in water. So we can't say ferric hydroxide as ferric and copper as a alkali metal. So alkali metal only group 1 and group 2, it is better to say, because they are strong. They dissolve in water to form alkali easily. But about these metals, they do not form alkali easily. and so we can't say others except group 1 and 2 others metals as alkali metal.
Sir, FeOH3, how do you read this compound?
Ferric hydroxide.
Ferric.
Ferric hydroxide. Fe has valency 3, ferrous and ferric. Ferrous has valency 2, ferric has valency 3. This is ferric hydroxide. Ferric has valency 3, hydroxide 1, crisscross, FeOH 3.
And that is cupric hydroxide.
No, cupric. This is that one. Yes, this is cupric hydroxide. Good. I was thinking about the second one. Yeah, cupric hydroxide. But it is well known known as copper hydroxide. Usually we used to take copper has valency 2. Hey, in case iron also we used to take 2. That's why we have to mention here ferric hydroxide. Otherwise it is iron hydroxide also. But ferric hydroxide, so that we can easily identify this is a metal having valency. This is iron having valency 3. Okay. In case of cuprous hydroxide, suppose if it is CuOH, in that case you have to mention cuprous hydroxide. But as a well-known valency of copper is 2. Okay. And well-known valence of iron is 2 also. So ferrous hydroxide, no need to mention ferrous iron or hydroxide, you can say copper hydroxide, you can say. But it is better to say, if possible, tell ferrous, ferric, copper, cupric. Hey, according to on the basis of their radical. Okay.
Okay, sir.
So now physical properties of base. So it is bitter in taste. Right, tarro bhaन्छौं हामीले त्यो करेलाहरु जस्तो खादा चाहिँ त्यसै tarro. Then it is soapy in touch. You have touched I think कतिटा कुरालाई टच गरेर अथवा त्यो करेलाको काटेर जुसलाई त्यसको त्यसलाई टच गरेर चिप्लो पनि भइराखेको हुन्छ, साबुन जस्तो चिप्लो भइराख्छ.
करेला बेसिक हुन्छ.
बेसिक नेचर मान्छ हो करेलालाई tarro. Okay. After then, the strong base is good conductor of electricity, and it turns obviously red litmus. Acid turns blue litmus paper to red, so it turns red litmus paper to blue. Methyl orange लाई उले चाहिँ red मा convert गर्छ, methyl orange लाई ले yellow मा convert गर्छ. In the same way, phenolphthalein into pink color मै रहन दिन्छ, यहाँ change गर्दैन, तर त्यहाँ चाहिँ colorless हुन्छ. Okay. After then, chemical properties of base. So one of them, base reacts with acid to give salt and water. यसमा त मैले बोल्नै परेन. So just as of the acid reacts with base to give a salt and water. Here is the base react with acid to give salt and water. So the reaction will be same. So you can write accordingly. No problem. You can write the above reaction, previous reaction also. So here is KOH, potassium hydroxide. So potassium hydroxide, so it is a base or alkali, we can say. Sulfuric acid is an acid. So base reacts with acid to give salt, and this is double displacement reaction, as I told in the previous class also. So K combines with sulfate radical. So potassium and sulfate in cross. Potassium has valency 1 and sulfate has valency 2. So after then it will form K2SO4 and the remaining S2NO, that is S2O. Okay. So H and OH, that gives S2O. Sorry. After then, calcium hydroxide reacts with the base, sulfuric acid, again the same process, and you will get calcium sulfate. Calcium has valency 2, sulfate has valency 2. So CaSO4, because and H and OH, that is water. After then, magnesium hydroxide and hydrochloric acid. Magnesium has valency 2, chloride has valency 1. So magnesium chloride, valency exchange MgCl2. Okay. After then, sodium oxide. Because of these different valency, I used to take different metals. So sodium oxide and hydrochloric acid. Sodium has valency 1, chlorine has valency 1. So sodium and chlorine crisscross, sodium chloride, and another is water. After then, magnesium oxide and hydrochloric acid. Magnesium combines with chlorine. So magnesium has valency 2, chlorine has valency 1. So this is magnesium chloride by crisscross method and S2O. Okay. Ammonium hydroxide plus nitric acid. So ammonium, NH4 has valency 1, nitrate has valency 1, so NH4NO3, and the rest is S2O. So this is reaction chemical properties where base reacts with acid to give salt and water. After the next one, alkali. Alkali, this is not base. Okay, metallic hydroxide. So metallic hydroxide reacts with water to give respective carbonate salt along with the production of water. For example, magnesium hydroxide is an alkali. It reacts with carbon dioxide and then it will form magnesium carbonate. Don't ask, sir, this is look like a double displacement reaction, but outside output is not correct. You sabai ठाउँमा लागु हुँदैन, you know that. So this is exceptional case, we can say. Though it is a, we used to say double displacement, but we can't say. Hey, because carbon dioxide is a compound, magnesium hydroxide is compound. So compound, there should be double displacement reaction. It behaves as a double displacement reaction. We can tell it as a double displacement reaction, but we can't ionize just like a double displacement reaction. Hey, we can't exchange the molecule like a double displacement reaction.
Sir, can you repeat the last statements which you said?
I want to repeat it again. Magnesium hydroxide is a compound. Carbon dioxide is a compound. So compound and compound, we learned that compound and compound, that is a double displacement reaction. It is a double displacement reaction. I want to tell about this. It behaves as a double displacement reaction, but completely it does not. We can say that ions are exchanged here like that in other double displacement reactions. Okay, so here if you see carbon and oxygen, we cannot break it into radical like Mg and O, after then C and OH like that. It cannot be break up, and that's why we can say magnesium. This is a special case, we can say, where double displacement reaction, it behaves as a double displacement reaction, but the output does not form by the exchanging of radicals. Understood, Abhinav?
Yes, sir.
ल एक्सेप्सनल, मैले बारम्बार भनेको छु केमिकल रिएक्सनमा धेरै एक्सेप्सनलहरु हुन्छ. ओके, इन द सेम वे क्याल्सियम
सर अनि सलाइभा चाहिँ एसिडिक हुन्छ है
के बाबु? एसिडिक हुन्छ, हो, त्यो चाहिँ हुन्छ. Okay, after then next one, potassium hydroxide plus carbon dioxide. So again the same, potassium खाली यति राख्नु कि give metallic carbonate salt को कुरा गरेछ, and salt will form by carbonates. Oh, so carbonate salt को लागि metal पनि चाहियो. So metal is here magnesium. So magnesium plus carbonate. Magnesium has valency 2, carbonate has valency 2. So magnesium carbonate MgCO3. Here also calcium has valency 2, carbonate has valency, so CaCO3. Potassium has valency 1 and carbonate has valency 2, so this is K2CO3. Sodium has valency 1, carbonate has valency 2, after then criss cross Na2CO3. Okay. Alkali reacts with alkali reacts with ammonium salt on heating to give ammonia gas. You all are well known about this. It was the, no, it was not, a bit different. Okay, ammonium chloride and calcium hydroxide. This you had learned in class 9. The class 10 mein chayeta, sorry, NH4Cl and COH2. This is the double displacement reaction, so no any explanation is required for that, I can say, because NH4 Cl is a compound, COH2 a compound, and as I told you in the previous class, NH4 and OH will combine. So NH4 and OH, that is NH4OH, and after then we have already discussed, if anywhere in the product NH4OH, we have to break it into NH3 and water. Okay, and the remaining CaCl. So Ca has valency 2, chlorine has valency 1, so this is CaCl2. After then ammonium carbonate and magnesium hydroxide. Same will happen here also. Magnesium will combine with carbonate, so magnesium carbonate. After then NH4 and valency 1, OH has valency 1, so NH4OH, and that will break up into water molecule and ammonia gas. NH4 is 2SO4. As I told you, this is just for formula balancing. So Na and SO4, Na has valency 1 and SO4 valency 2, so this is Na2SO4, and after then we have NH4OH, and after then balancing it. Okay, and another one is insoluble hydroxide are reduced from alkali by some salts. Insoluble hydroxide, some hydroxides are not too much soluble in water, and such hydroxide are replaced by alkalis. To look at copper sulfate and sodium hydroxide. Here this hydroxide and copper sulfate is double displacement reaction. So Na combined with SO4, Na has valency 1, sulfate has valency 2, Na2SO4. यो कपर सल्फेट इज इन्सोलुबल सरी हाइड्रोक्साइड एनीवे त छँदैछ यो चाहिँ जुन कपर हाइड्रोक्साइड भन्छ त्यो इन्सोलुबल हो रिएक्सन कहाँ गयो सके this copper hydroxide is insoluble in nature, so this insoluble hydroxide is formed, okay, or produced when copper sulfate reacts with NaOH. So Na combines with SO4, Na2SO4, and then copper hydroxide like this. FeCl3 plus again the same ferric hydroxide. We have already discussed about this. These are weak acid, weak base. So this is again formed the same. So do you have any confusion up to here?
Sir. सर केमिकल रिएक्सनहरु लेख्दा नि हजुरले भन्नुभयो कि लेफ्टमा रिएक्टेन्स राइटमा प्रोडक्ट त्यो त ठीक छैन तर हामीले फर एक्जाम्पल अब त्यो सेकेन्ड पोइन्टको फर्स्ट रिएक्सन जुन छ नि MgOH2 + CO2 गिव्स हामीले H2O + MgCO3 लेख्न मिल्छ है
त्यो त मिल्छ त्यो उल्टो गर्न मिल्यो प्रोडक्टमा अगाडि पछाडी जसलाई पनि लेख्न मिल्छ रिएक्टेन्टमा अगाडि पछाडी जसलाई पनि लेख्न मिल्छ तर युनिभर्सली नै हाम्रो के छ वर्ल्ड वाइड के छ भने रिएक्सन्सलाई लेफ्टमा लेख्ने प्रोडक्टलाई राइटमा लेख्ने यो कुरालाई चाहिँ हामी मान्यता दिने वी विल नट फर्गेट अबाउट दैट अरु कुरा जे हुन्छ गर्न पायो वी क्यान जस्तै यहाँ हेर न तिमीले कसैले मन लाग्छ NH3 can be written first then this no problem anything can be written because in the product all the things are found so anything you can write but you are not able to write this in this side and reactants in right side and by changing the arrow sir म त एरो चेन्ज गरिदिएकै हो नि एरोलाई त फर्काइदिए यसलाई अगाडि लेखे त्यसलाई पछाडि त्यो नगर्ने because it is a worldwide use system so please don't change it according to your wish अरूले गर्छन् सब भन
सर नि सी वाटर चाहिँ के भन्छ इन्जुरियस टु हेल्थ हुन्छ हैन त्यो चाहिँ किन
हैन त्यो त धेरै नै सल्ट हुन्छ भयो त्यसमा सल्टी त्यो सल्टको मात्रा धेरै बढी भएर हो त्यसलाई प्युरिफाई गरेर युज गर्न पाइन्छ नि
सर त सल्ट चाहिँ किन
सल्ट फर्म हुन्छ
चाहिँ कसै गर्छ
त्यो त धेरै लार्ज अमाउन्टमा सल्ट हुन्छ त्यो टर्रो पानी हुन्छ एकदम कडा पानी हुन्छ के त्यो पानी पिउनै पनि सकिदैन त्यस्तो कडा हुन्छ त्यति धेरै हुन्छ त्यो त्यसलाई त गर्न प्युरिफाई नगरेसम्म पिउनै नै हानि हैन थोरै पिहाल्यो नि मात्रै मान्छे मरि नै हाल्ने हैन तर त्यो
मैले हैन सर त्यो साल्ट नि है हामीले खाएपछि नि किडनीले चाहिँ त्यो साल्ट किडनीले साल्ट बाहिर फ्याक्नको लागि चाहिँ अलि त्यो बडीले अलि धेरै पानी युज गर्छ नि त्यही भएर झनै पानीको कन्ज्युम हुन्छ नि त्यही भएर झन् डिहाइड्रेसन भयो त्यो मान्छेले त्यो
हैन धेरै खाए पो त्यसरी हुन्छ त तर थोरै खाएमा मान्छेलाई त त्यतिकै हानि गरिहाल्दैन नि त्यसलाई खाएर पछि त त्यो गर्न सकिन्छ त्यसकारणले त्यति टक्सिक चाहिँ हैन ठीक छ ओके आफ्टर देन I think probably we have usage now. आज हामीले join गर्नु पर्दैन okay so usage of base only base we'll discuss today after then caustic soda so NaOH you know that is used to manufacture soap detergent we'll learn about soap and detergent in the same class later so till then it will used paper बुझिसकेको छ रायन भनेको यो नाइलन जस्तै हो नाइलनको एउटा आर्टिफिशियल सिन्थेटिक रबर हो रायन After then, caustic potash that is used to preparation soft soap, magnesium hydroxide or and aluminum hydroxide. दुईटै use गर्न सकिन्छ यसको मिक्सचर अथवा you can use any of this magnesium hydroxide or aluminum hydroxide to reduce hyperacidity because you know that acidity is caused due to presence of more acid in the stomach. Stomach मा acid को presence बढी भयो भने त्यहाँ चाहिँ hyperacidity हो. So to reduce this means this hyperacidity property we use to consume base so that base will combine with acid to form salt and water and acidic property is reduced and that's why magnesium hydroxide or aluminum hydroxide are used as antacid यो इनो on acidity गन के भन्छ नि त्यो इनो भनेकै त्यस्तै magnesium hydroxide or aluminum hydroxide or दुईटैको मिक्सचर हो and next one lime water or select lime is used as lab reagent to the vinegar. It is used to prepare plaster and bleaching powder. Okay, so ammonium hydroxide is used as lab reagent and it is used to prepare chemical fertilizer. Ammonium hydroxide bata ammonium sulfate, ammonium nitrate haru banaउन सकिन्छ. I think this much only. Oh, it is. Quick lime is used for manufacturing cement, calcium oxide. Hey, it is also used for softening hard water. तिमीहरुले पढिसकेका छौ hard water लाई soft बनाउने तरिकामा. Okay. So these are some properties, some uses given in our government book and that we have written here. So this is all about the base. Okay. In next class, we'll discuss about salts and you'll get this homework today Though I am not going to check it, you know, as I told you, from tomorrow I'll start probably. So please, you have this week, hey, up to Saturday, Sunday morning, you have to complete this arc of both energy chapter and this acid base and salt also. We can, oh sorry, acid base only, because salt will not continue this week. In next week, obviously will. So up to acid and base homework you have to submit. Please don't forget. So do it. And if
Sir,
Abana,
so what is lab reagent?
oh, just wait. Let's stop money. Alt P. Okay. And